Hey, welcome back to Fan Mama Physics. In this video, we are going to go over examples of how to write an equation from a particular pattern or a scenario. So this is part 2 of, should be 5.1, okay? So let's get down to business. Example 3 here. The pattern in each table continues below. For each table, describe the pattern that relates to V to T, write an equation, then verify it. Okay, so I'm going to kind of extend. Imagine I'm going to keep writing on this side to identify my pattern. The first thing we want to do is we want to find the pattern as we go from one row to the next. So from 8 to the 13, you might notice that we have to add 5. Let's see if that pattern continues. It does continue. I do have to add 5. I have to add 5 again. So every time I am adding 5. Okay, so if I had to take 5 and I had to take the term t, which is my starting term, it's as if I need to take 1 times 5, 2 times 5, 3 times 5, 4 times 5 to multiply the number of times that I need to add 5 to get my final answer. Because the first the second term, I have to add 5. Third time, I have to add another 5, and so forth. So again, I need to take something in which the variable t does, whatever t does, it changes depending on what the value of t is. And depending on what the t value is, it will affect what my v value is going to be. So if I take 5, which is my multiplier here, and I multiply by my t, this is going to give me whatever, it should give me whatever term value that I have over here. So let's check that. And we want v on this side. V is equal to something something plus 5t. But 5, if I plug in 1 as t, that's not going to work, right? Because 1 times 5 is going to be equal to just 5. So to make this work, to get 8, I kind of have to add 3, okay? So we've checked for the first one. So the first one works, okay? Let's check the second one. Okay, so second one, I need to get 13 if I plug in 2 in the t. So I would get 5 times 2 plus the 3. Oh, I should really write it on this side. I can swap it around. I can write 5t plus 3 instead. It's the same thing. Okay, so 5 times t, which is 2 for our second row, plus 3 over here, is going to give us 13. Oh, it's starting to work. Okay, 5 times 3 plus 3, this is 18. Nice. And last but not least, 5 times 4 plus 3 equals 23. So this works. Our equation is going to be v equals to 5t plus 3. Okay, so remember our first steps. First was to figure out the pattern. Using the pattern to figure out how the pattern relates to the term number, which is t, the first variable that we have. Once we found that relationship, then we can work out the rest of the pieces. Okay, let's try again on number b. Okay, let's find again the pattern. Ooh, number's going down this time. So this one, we're actually subtracting 3, okay? And not adding. So in terms of our pattern, again, we're going to relate v to something something t. And this time, because we're taking 3 away, I'm going to need a negative sign, and I'm going to have my 3 here. And I want to multiply by t to give me whatever term value v is. So as my t increases, the t number goes up, the more times I have to subtract the 3. So that's what this is. But if I put in just the 1 here, I just get negative 3, and that doesn't make sense. So what do I need to add to negative 3 in order to give me 34? That's 37. So I add 37 here. Okay, let's try this equation a few times with number for 2. So v is equal to negative 3 times 2 plus 37. Do I get it? Negative 3 times 2 is negative 6. Negative 6 plus 37 is 31. Hey, it works. Let's try again. Okay, negative 3 times 3 this time plus 37. So this gives me negative 9 plus 37. That's going to be 28. Oh, hey, yeah, there you go. It equals 28. And then negative 3 times 4 plus 37 and that's going to be negative 12 plus 37, that's going to equal 25. Hey, it's checking out. So this is our equation here at the top. V is equal to negative 3t plus 37. Okay, so I would say that if all in doubt, verify your equation, because sometimes it does take a little trial and error to get it right. Okay, so let's go down here to a few word examples. Word examples might even be easier. Well, let's try the first one. Example 4. An airplane is cruising at a height of 10,000 meters. It descends to land. The table shows the height of the plane every minute after it began its descent. The height of the plane changes at a constant rate. So we know the change is constant. Find the relation between time and the height of the plane. Okay, so in fact, this is kind of like what we've been doing before. Okay, maybe what we will do is I'm going to give you a chance to try this problem. Okay, you're going to find out the pattern going from one row to the next. You're going to try to come up with the equation, verify it, and to show that you have indeed the right equation. So a good time to pause the video to try 4. Okay, so let's do this one together. So let's figure out the pattern. From 10,000 to 9,700, looks like I have to subtract 300. Again, subtracting 300. And that's it. Okay, our pattern. Remember, we want h to relate to t. So I have h here as our final answer, and this is equal to something we do with t. At 0, it's at 10,000, and then at 1, it's 9,700. So I'm probably gonna have negative 300 in here, because every minute the plane goes down 300 meters. So if I multiply that by t, the larger the number of t, the more minutes have passed, the lower the plane has gone down, the more it has descended, the more we subtract 300 meters, okay? So that's going to be t, and then we're going to try this out. If I put t is equal to 1, or even t as 0, actually let's try that, since we have it there. And this is interesting, which we'll talk more maybe in later lessons. But here, imagine t is 0. So our starting variable is 0. If t is 0, then h is 0, and that doesn't make sense. H cannot be 0 at t is equal to 0. In fact, if I put 0 here, then this whole thing becomes 0. I need to add 10,000. I need to add 10,000 here, because if I put in 0, that makes this 0. I'm left with 10,000. So let's try with t equals 1. Let's see if that works. So I have negative 300 times 1 plus 10,000, and that gives me 300. Did I say 3,000? Sorry. 10,000 minus 300 gives me 9,700. Hey, it's checking out. Let's try the next one. Negative 300 times 2 plus 10,000, that's going to be negative 600. Plus 10,000, that's going to be 9,400. Okay, I think it's working out. Maybe let's just try one more before I run out of space. Okay, and again, this is going to be minus 900. I'm going to be left with 9,100. It shows that it's checking out. Okay, so this is my final equation. I'm going to write here, h is equal to negative 300t plus 10,000. You could write it in the opposite way. That doesn't matter. Here, when time increases by 1 minute, then height decreases by 300 meters. That's the pattern. Hey, we got a follow-up question. C. Determine the height of the plane after 15 meters. Well, 15 minutes. We just substitute the time in. That's it, because we have the equation, right? So our height is going to be equals to negative 300, and this t is in minutes, and so I just plug in 15 directly, plus 10,000, and if I put this into my calculator, I am going to get negative 4,500 plus 10,000, and my answer is going to be 5,500 meters is my height of my plane. Just checking. I'm here. I'm gonna check my answer. Okay, looks good. All right. Hey, we got it. Yeah. Okay, last question here is a word problem. So I'm going to quickly go over this one. Sarah calls a taxi. The taxi driver charges a fixed cost of $3.60 and $1.50 per kilometer that she travels. So we have a base rate, and every kilometers you go, you charge this many amount more. Write an expression for the fare in terms of the fixed cost and the cost per kilometer. So we don't know how many kilometers she will go. That's going to likely be our variable. Let's say that is d as our distance, okay? So that's our unknown. I will tell you that because why? I want you to try this problem. So I want you to try to find the expression, and B is like A, essentially, if you know what I mean. It's okay, we'll go over it. And then C, determine the cost for an 11-kilometer trip. If you're absolutely stuck, try C first. See if you can use that and work backwards to find the equation. Or, if you're really stuck, make a table, okay? Well, do whatever you gotta do. But how am I gonna do this is I'm gonna try to convert the problem into the equation directly, because it hopefully shouldn't be too hard after you practice it. So, good time to pause the video, try example 5. Okay, so I'm going to go ahead and do this. I want an expression for the fare in terms of the fixed cost. Okay, so I know even if I don't, the minute I get on the taxi, I have to pay $3.60. That's pretty cheap, actually. And then every kilometer I travel, so I'm going to add this amount, but this amount depends on how many kilometers I traveled, which I have chosen D to be my variable. So I'm going to put 1.50, and I need to multiply this by D. So D, if D is 1, then I pay this fixed cost and $1.50. If I go 2 kilometers, then I have 2 times this value, this here, then I add my fixed cost. And 3 kilometers, so forth. I do the same thing. So this is my expression. And D is going to be the distance that I've traveled. In terms of the equation, it's basically A, but I write the equal sign. So I write my expression, which is this one that we found earlier, and then all I need to do is I need to equate that to something, which is the amount we need to pay. I'm going to put F as the fare. So fare is equal to this expression. So if I know what D is, I can figure out how much I need to pay. So that's what I mean. A and B are very similar. I just have to write an equal sign and attach a variable to the fare, which is F. C, okay, so if you did that first, that's okay. But now what we're going to do is we're going to use this equation here to figure out the cost for an 11-kilometer trip. So fare is equal to $3.60 plus $1.50 times the distance, which in our case is 11 kilometers. And I'm going to do that, okay? If you're wondering about units, this not the purpose of this video, so I'm going to, how they cancel, then don't worry about that. If you're curious, you can always ask me later. Okay, so let's calculate this. This is going to be, what is 11 times 15? 16.5. Okay, so that's $3.60 plus 16.5. Okay, so then I add the 2, which then this is going to give me 0, 1, and then that one comes over, becomes a 0 to $20.10. Okay, and don't forget, please put in the 0 here because that's proper money notation, even though it's a 0. Don't forget your $ for the units, and this is our final answer after finding out our equation. Okay, so this is the idea of patterns. So it's kind of like a puzzle. You're trying to figure out a puzzle, but you have ways to verify it, which is great, and take full advantage of it. Okay, so that's it for today's lesson. Thank you for watching. Hopefully you learned something that you can apply yourself. Good luck, Fat Mama Physics signing out.